Okay, direct variation means as y goes up, m goes up, or x goes up. Usually you'll see this as y equals kx. K is called some constant of variation. Whether y double goes up twice as much as each x, or half, or 1.3 times as much, there is some constant of integration. Um, this is not direct variation because I've got something added. Direct variation must go through 0, 0. Inverse variation is going to look like this. You'll sometimes see it written as x times y equals k, but that means as x goes up, y goes down. So that's inverse. Yeah. So here we have the volume of a sample of nitrogen is directly proportional to the temperature. The sample volume of nitrogen is 600 milliliters at temperature 300 Kelvin, and it becomes 700 milliliters at 750 Kelvin. Or 350 Kelvin, yes. So describe a formula that describes the volume as a temperature of T. So volume is directly proportional to temperature. 600 equals K times 300. K equals 2. I'm not sure why I need the second one. And this would be V equals 800. Okay. Things can vary directly with a square, like area varies directly with the radius squared of a circle. A equals pi r squared, or a cube, or any other power. So here the distance that a ball rolls down an inclined plane is directly proportional to the square of time. So the first thing I have to do is write my equation. Uh, 1 second after the release, the ball has rolled 0.9 meters. So K equals 0.9. 0.9. So then my equation is D equals 0.9 T squared. How far will the ball roll in its first 4 seconds? Point 0.9 times 16. What's 0.9 times 16? Like, I don't know offhand either. No. Okay, so we talked about inverse already. One of the keys to inverse is that x and y are never 0. Because obviously we can't divide by 0, but you can never equal a constant that's 0 unless your constant is 0. Okay, so on a balanced seesaw, the weight varies inversely with the distance of the object from the fulcrum. So one of the keys is always writing these out. Weight varies inversely with distance. Weight equals K over D. If Matthew weighing 140 pounds is sitting 7 feet from the fulcrum, yes. I think that's a different culture's spelling of it. Where should his brother Harvey, who weighs 98 pounds, sit to balance? Well, first thing we need to do is solve for K. K is 7 times 140. That's 980. He will have to sit further away. Oh, so my general equation is y equals 98 over K. 7 times 140. He's got to sit 10 feet away. Okay, let's get the next section loading. So modeling with a cubic function. Yeah, we did. Okay, cubic modeling. So, an open top box, the famous box problem. 15 by 30. How do you write the volume of the box? Mm-hmm.
Minus 2x is 15 minus 2x times x.
Mm-hmm. Hey, you've done this enough times. It says explain why. I'm cutting out. Uh-huh. Find a model. So this is my model. Whenever it says model, it means equation. And find the values for x, which is meaningful. That's essentially the meaningful domain. What is your meaningful domain on this? 7.5. 15 minus 2x. X is 7.5. Honestly, it's not really included. So it says, because x would be, we'd have a negative dimension on that one. Which would make you hold negative volumes. It has to be the shorter one. So now it says graph it and find the maximum. So we'll go to our graph. I can remember that function. We'll go to a graph. So notice our graph shows a whole lot of things. Let's come up with a window for this that doesn't show the extras. Let's window. That works. So all I did was put my x in my meaningful domain. I can find the maximum. 3.17 is my x. My maximum volume is 649.5. Okay, another one. You work in the design department for a soft drink company, and you are experimenting with new cylindrical containers for beverages that are slightly narrower and taller than the standard container. For your experimental container H, the height of the container measured in centimeters has to be 5 times larger than the radius of its base, also measured in centimeters. Find a formula that describes the volume of the container. Does it have to be exactly 5 or? Okay, it has to be exactly 5. So we know that 5r equals h.
Wait, what?
The height has to be 5 times the radius. So my general formula here for volume of a cylinder, so pi r squared times 5r or 5 pi r cubed. Find the volume when the radius is 3. V of 3 is 5 times 27. 135 pi. So I plug it in. If the volume of the container is to be 400 cubic centimeters, explain why 80 equals pi r cubed. Well, that's easy. 400 equals 5 pi r cubed. Divide by 5. So to do this explanation, yeah, and I think you could do it simply by solving. Say I set up the equation divided. Explain usually valid mathematical steps get you and count as an explanation. There is going to be things on your exam that are like explain. Yeah. Fitting a cubic model to data. Doing a, okay, doing a cubic model. Let's do this modeling because I think you could use a review on the Inspire. So we're going to put this in the Inspire. Do you remember how to do that? 9, 11, 13, 17, 19, 21.
Spreadsheet. Label here, what are we listing?
Let's see here. Speed hours. Or engine and boat. How about we'll do engine and boat?
That name?
Yes.
So like keyboard is like set up like not like a keyboard.
Yep, that's due to College Board.
Great reasoning one.
It would be too easy to put notes in, I guess, theoretically.
Speak longer.
Uh-huh.
I don't think it's gonna stop kids who are gonna take notes, taking notes.
I agree.
Because if you're willing to go to that much for to take notes anyways, I think
8.88, 9 point.
cheating, I don't know, is that cheating to have notes on your calculator? I feel like it is.
On an SAT, yeah.
They like go to cheat and like things you have to be able to do sometimes. Like,
10.98, 12.56.
It's easy to like learn the material.
Uh-huh. Oops, there's a 21 here.
I'm
15.54. Which ones do you need to see?
skip smart.
I can put the whole data back up.
Sixteen, 17. 12.56. You're gonna control and add another each.
Mhm.
Yeah. Statistics, your independent select engine
Mhm.
and dependent variable vote. And
And that looks kind of cubic-like.
this doesn't tell us.
It says this is cubic. This- That looks pretty good. It asked me for it at 2,500. Wait a second. We got a calculator. What does it ask me for? Use your model to estimate the average speed of the boat for an engine speed of 2,500 RPMs. Huh? Okay, so this is in hundreds. This is 900, 1,100, 1,300. So that's 2,500. Did you notice where it had allowed you to choose the function name? So when I'm doing cubic regression, save regression equation 2, F1. No, like function 1 on your Inspire. 25, because X was in hundreds. Knots, I think. Yep. Sure beat plugging in 25 for all those and typing it out though. Okay, modeling with exponential functions. Okay, growth versus decay. With growth, so they're giving you the compound interest formulas here. With growth, it's 1 plus the rate. With decay, it's 1 minus. So the part that's taken to the x for growth is b is, if we look at it as ab to the x, b is greater than 1 for growth. B is between 0 and 1 for decay. So Hugo deposits $900 into an account that pays 4.55 interest per annum compounded monthly. Find an equation to model how much money Hugo has after 2 years. 900, 1 plus 0.0455. They're going to give you the annual interest rate, but they're doing it monthly. Okay. It will say interest per annum all the time. That is just your interest rate. Describe why the amount of money will can be described as exponential growth. It's exponential growth because it's the power of my exponent. Calculate how much money he has in the year after 10 years. I guess it said per X years. I probably should use the variable that they say. You might get away with you calling it T, but it's best to use what they say. And how long will it take before there's 3,500 in his account? So we're simply going to plug in 10. So they substitute 10 in for X here in part C. How do you think you'd solve part D? They didn't show it very well. You're going to solve part D by solving by graphing. And so you should show if you did this, you're showing something that looks like this. Let's call that f of x. And we're showing this point 29.9 3500. And so we're going to call that 30. Yes. Yep. So that's kind of what they're looking for there. You could solve that by hand with logarithms if you wanted. Wouldn't feel like it. Oh, they did show it here. Okay. Example 3, radioactive decay. This time, instead of doing a B, we're using E as but I'm doing E to the negative K. Okay. They'll do negative for decay, positive K for growth. Um, the amount of radius modeled by this function is determined that after 20 years, the amount of radioactive decay present is 50 grams. Show the amount of decay material decays exponentially. Well, okay, their justification is the negative K means that it's 1 over E. So it's decay and my variables, it's an exponential function. Okay, that makes sense, right? So finding the initial value, you're plugging in 0 for T. That's just 250. That makes sense? Find the value of K. To find the value of K, I need to use my other values, my 20 years and 50 grams. So 50 equals 250 e to the negative K times 20. I'll divide both sides by 250, giving me 50 over 250, which is 1/5. ln 1/5 equals negative 20K. K equals ln 1/5 over 20, which by the laws of logs, that's ln1 minus ln5 over 20, and ln1 is 0. So if I want to know how much is left after 80 years, I'm going to do m of 80. Oh, that's over negative 20. So this ends up being ln5 over 20 for k. And because it was negative k, I have to plug it in like this. And I just plug that into a calculator. That makes sense? And we get 0.399 grams. I knew it was going to be pretty small. Okay, a drug is developed to depress the temperature of a patient during a fever. The model for the drug is given by the equation T of T equals T times 0.84 to the T, where T is the temperature of the patient above 37 degrees Celsius, and T is the time after the drug was given. Determine the maximum temperature of the patient and the time when it occurs, and how long does it take for the patient to return to within zero point 0.5 degrees of 37 Celsius. So I would just go ahead and graph this. Oh, okay. It's above 37. They ask, how long does it take to return to within zero point 0.5? So this one graph can show both the maximum and if you have the 0.5, you can show that 21.6 hours. Fitting data to an exponential function. We're going to do the same thing we did with cubics. Does this one make sense? Do the same thing we did with cubics for fitting data, except you're going to choose exponential regression. Express it in that form. I believe it's going to give it to you and how much material will be left after 20 days. You're just plugging it in. So you get this. It looks like we have an exponential decay. This is in the form they asked me for. Wait, is that in the form they asked me for? No, it's not in the form they asked me for. So here's what we get for our function. So they gave it an a0 b to the x. What the thing asked for is a0 e to the negative kx. Does that make sense? So we're using this to solve because that is b. Because e to the negative k to the x is this. So that's this b value. So if I've got 0.7937 equals e to the negative k, I ln both sides. And then I divide by -1, and I get negative ln 0.7937 equals k, and that's my k value. Wait, wait. Maybe they didn't ask for the negative. They do not give me the negative, so I skipped this extra negative. That's a positive.
It's been paused 3 times already.
Yeah. And then we plug it in. Modeling with sinusoidal functions. So general form of a trig function. If you're used to this, we've kind of used to. I often write them like this. Where D is my center line or principal axis. C is my phase shift. 2 pi over B equals period. You're also going to see period written with a capital T. And A is amplitude. Amplitude T equals 2 pi over B. So T being period. And they're not going to do a lot of phase shifts.
We did this.
Mm-hmm. D equals principal axis, which we called centerline in pre-calc. Notice my B is factored out from the x minus c. My C, my B. My B is factored out. B,
Speaker.
uh-huh. Otherwise, your phase shift is C over B. So if I do it with it not factored out, not much changes. The only thing that changes here is this becomes C over B. If I'm dealing with the red one. So for this sinusoid, where x is in degrees, find the amplitude period of the principal axis. Amplitude is 3. The negative just means it reverses, it goes down first. Amplitude is really just about how tall it is, so the wave is repetitive. Yeah, absolutely. T equals 2 pi. In the case of degrees, the over 2, so 180 degrees. And principal axis is -1. You hopefully remember from pre-calc that the cosine is simply a phase shift of the sine. The cosine starts up on the axis for positive, down for negative. Sine goes through the origin, goes up first for positive, down first for negative. Unless there's a horizontal shift. So, graph this to determine the numerical values of the specimen. Where's my center line on this? I guess it's at -2. So what's my amplitude? 4, right? And my 90 degrees is my period, right? So B equals 4. A Ferris wheel with radius 25 meters is rotating at a rate of 3 revolutions per minute. When t equals 0, the cabin starts at the lowest point of the wheel. So let's use a negative cosine here. It's starting in the down position, which is 3 meters above the ground, right? The model for the height h in meters of the cabin as a function of time. So we got a Ferris wheel. It's just an enclosed Ferris wheel. Starts at the lowest point is 5 meters above the ground. So my center line or principal axis is going to be 30 because the radius is 25. It's making 3 revolutions per minute. Believes that's right. Why 18t? 3 revolutions per minute. It completes 1 revolution every 20 seconds. Oh, And T is in, I was thinking it was in minutes. They want T in seconds. So it's every 20 seconds. So that means my period is 20 seconds equals 360 over B. And B was then 18. So it's not 3, it's 18. That makes sense?
Yeah, so to get B or divide for setting
Period
revolutions.
360 over B. And that's because they're doing this in degrees. It would be different if you did it in radians, but they like to do these in degrees. I think it's a little weird, but okay, that's the end.